Now let's look at a function we've been doing a lot of work with already this year, and that's the quadratic function. Now remember what we've done before. Our quadratic function's in the form y equals ax squared plus bx plus c. Now the thing you probably do know, and you might have done a little bit before, is when you graph a quadratic function, you get a parabola. Now, in the junior school, you probably graphed some parabolas before. Now, you've graphed them using a whole set of points. We really don't want to do that in the senior school. In this course, what we want to do is determine a few things about our parabola from our equation. So we look at our equation first, and then see a few things. The first one is, what's the sign in front of ax squared? Now, if a is positive, then our parabola is going to be concave up. If it's negative, then it's going to be concave down. Now, obviously, it can't be equal to 0 because the definition of our quadratic function, a cannot be equal to 0. Because if a is equal to 0, then we get 0x squared, and it's not a quadratic function anymore. It's only going to become a linear function because it's y and a bx plus c. So the quadratic function has an x squared in there. Y to the power of 1 has an x squared in there. It can have a bx, might not have to, because b and c could be equal to 0. Y equals x squared is pretty much the general parabola. So, and that's the most simplest one. So it doesn't have to have b or bx or c, but it does have to have an ax squared. So a can't be equal to 0. So it's either one of this one, and we either get concave up or concave down quadratics. Then really what we want to know is two things. Where does it cross the x-axis? Where does it cross the y-axis? Now, what we want to do that, the first thing, getting where it crosses the y-axis is the easy part, because all we need to do is sub x equals 0 in the equation. So if we've got x squared minus 5x plus 6, and we sub x is equal to 0, because again, why do we sub x is equal to 0? Because along the y-axis, x is equal to 0. We saw that with our linear functions, that was the equation of of the y-axis. So when x is equal to 0, y equals 6. That's always easy to find. Like, there's never excuse, no matter what function you have, as long as it's y in terms of x, it's really easy to find your y-intercept. Sometimes finding the x-intercept is not as easy, okay? But for quadratic equations, it is, because we've been doing a lot of this. We've been solving quadratic equations. We've been solving a lot of these types of equations. So whether we solve it using quadratic formula, we haven't done completing the square methods, but if you know completing the square and you want to do that, we'll go ahead. But most of the time we'll be able to factorize. So where it crosses the x-axis, we know that the y value is equal to 0. And we've talked about, when we were doing quadratic equations, why we wanted to do quadratic equations. And we said this was the reason why we wanted to do quadratic equations and solve quadratic equations, so we could graph parabolas. And we'll do a lot of work with parabolas as we go through. But to do it now, this is all we really need to do. Y is equal to 0, so we sub 0 in, and we solve for x. So we factorize, and we know if it's going to be equal to 0, x is equal to 2, or x is equal to 3. And there's our value. So our x-intercepts there, our y-intercept, because it gets cut off a little bit, but our y-intercept there at 6. And then if we can look at other things as well. If we want to know where it turns here, and some of you are looking and go, well, I know it turns halfway between the 2 and the 3. And that's exactly right. You can pick the 2 points that have the same y values, and it'll turn halfway between those. And we'll do a lot more work with that when we do the quadratic polynomial and see where if you're really interested, the axis of that parabola would be x is equal to minus b on 2a. And that comes from the equation there. A and minus 5 is b, and c is 6. So we know what we subbed in there before. You might be looking going, well, that comes from the quadratic formula. You would be right, it does. Okay, so looking at some graphing here. What does it look like? Well, 3x squared. Well, they see the 3. We know it's going to be concave up. And you know that you're going to have x squared. So it's going to be only touching the x-axis when x is equal to 0. We get y is equal to 0, and the same thing, when y is equal to 0, well, we're only getting one value. It turns at the parabola, at the origin. That parabola turns at the origin. So it's going to look at that. It's going to be symmetrical. Okay, we'll talk more about odd and even functions later on, but it's going to be symmetrical there, and that makes life easier. And the higher this number is, 3x squared, and you probably played around with this in the junior school, you know the larger that number is, the steeper it starts to get. Now, my computing program here is drawing it nicely to scale. We're not worried too much about scale. If you are, you can plot a point and go -1, 2, 3, and 1, 3, and have that nice. But it should look reasonably symmetrical. Again, you're drawing graphs freehand, so we're not expecting great masterpieces, but nice and neat and tidy graphs is what we want. So looking symmetrical there about that point and concave up. Again, x squared plus 1. If we looked at x squared would be a graph that looks like that. If I get it done a little bit neater. So there's the basic shape of x squared. It's concave up. And all we've done is take the graph here and shift it up 1 unit. And that's what the effect of adding the constant there does. It's really the same graph as y is equal to x squared, which would go return at the origin, but shifting it up 1 unit pushes it up. So if we solve that, we get no factors, so you can't find a x-intercept, and if you tried to do that, then that's good, and you would see there's no x-intercepts, and that's what it means. It comes down and turns and does not go through the axis. So basically, if you can graph x squared, you can graph x squared plus 1 because it shifts up. Y equals x squared plus x. So what are we doing here? Well, again, our x-intercept, our y-intercept, well, when x is equal to 0, y is equal to 0, it goes through the origin. And when y is equal to 0, to get our x-intercepts, we can set it equal to 0, factorise, get x is equal to 0 and x is equal to -1. So that's where it's going through the axis and it's concave up. So that's really all we're looking for at this present time. Where does it go through the x-axis and the y-axis? And it happens to go through at the origin, so that's a little bit special. And we're able to get our shape of our graph. That's really all we want to concentrate on at the moment. Y is equal to x squared minus 2x. Again, when x is equal to 0, it goes through the y-axis at the origin. And then we set y is equal to 0, and then factorise, and we get x is equal to 0 and 2. So there's our y, there's our x coordinates there. So it's concave up, going through x is equal to 0, x is equal to 2. And then the last these couple of questions, minus x squared, we know it's going concave down this time. And if we factorise this one, again, you can do it a couple of ways. If you know what x squared looks like, then you're graphing x squared and getting that shape, then minus x squared would be exactly the same, except it's concave down. So the minus x squared and putting a minus in front actually just reflects it in the x-axis. So that's a bit of an advanced technique, but it's not a hard technique really. So that's what that part does for. And then because it's adding 1, we're shifting it up 1 unit. So really, that curve shifted down 1 unit is x squared minus x squared, and then we shift it up because we're adding the 1 there. Again, you could change it around to be 1 minus x squared and set that equal to 0, and then you could get 1 plus x squared, 1 plus x, 1 minus x equals to 0, which means you're going to get x is equal to -1 and 1. There's your x-intercepts. Okay, your y-intercept when x is equal to 0, it's +1, so that's where it's with y-intercept. So you're able to do it that way if you're inclined. Either way, as long as we're getting the graph correct, that's really what matters. X squared plus 5x plus 6. Again, well, where does it go through the y-axis? Well, when x is equal to 0, it goes through the y-axis at 6. And again, my graph's been cut off a bit, so it'll go through at 6 there. But again, we factorise, or if you want to use the quadratic formula, if you can do that to solve your quadratic equation, gives you x equal -2, x is equal to 3. It's concave up, going through those two values on the x-axis, and going through 6 on the y-axis. So that's what we're looking for. They're the keys we're looking for. So in the next one, again, concave up. So there's our first clue. Where does it go through the x-axis, y-axis? When x is equal to 0, so it'll be 12. And my graph is cutting it off there. So again, when you are doing it yourselves without a graphing program, I have to rely on a bit of scale to play with this. You really don't have to worry about scale on your diagrams. If you had looking like that and then going off here and cutting at 12 up here and going, well, the scale's not right, it really doesn't matter as long as you're indicating that's where you're going through. It's cutting through 12 and it looks like a parabola. And because I've set y is equal to 0 and factorised and got x is equal to 3 and x is equal to 4, I'm able to get those 2 values as well. So I know where it cuts through the x-axis. Again, it doesn't have to look spectacular and doesn't have to look to scale. That's okay, as long as you're including the critical points of the shape of the curve being correct. So it's got its correct concavity, you've got the correct y-intercept, you've got the correct x-intercepts. That's really what we're looking for. Y equals x squared minus 4x plus 3, again, when x is equal to 0, y is equal to 3, so then you can see it's cutting through y is equal to 3 there. And then we set our y value to be 0, so we set our quadratic there to equal to 0, factorise and solve, so 1 and 3 are our solutions there, so you can see that's where it's going through the x-axis. So coming down through 3, going through 1, going through y, x is equal to 3, and then turning back up. So, and it's going to turn it too, because it's halfway between. So it's halfway between there. So keep that in mind. Again, we're not really looking for that at this point in time. We will at some stage, and we'll play around with that stage. So you could try and be a little bit neater and try and get a little bit of accuracy there, but we're not looking for super accuracy at this time, just looking for those critical things.